9.1-2 final example problem number 1. A weight of 0.200 kilograms is suspended from a string and spun in a circle with an angular velocity of 5.0 radians per second. The string passes through a vertical tube and comes out the bottom. Initially, the radius of the circle is 0.25 meters. What is the new angular velocity after the radius is decreased to 0.20 meters? So documenting our given information, we have a mass of 0.200 kilograms, an initial angular velocity of 5.0 radians per second, an initial radius of 0.25 meters, a final radius of 0.20 meters, and we are looking for the final angular velocity. This is a conservation of angular momentum problem. Therefore, our beginning is to state that the initial angular momentum, L1, is equal to the final angular momentum, L2. Now, in the notes, we saw that L was equal to I omega. Therefore, L1 becomes I1 omega 1, and L2 becomes I2 omega 2. Now, omega 1 we have, and omega 2 is what we were looking for. However, we do not have I. Fortunately, earlier in this class, when we were talking about rotational motion, we found that I, the moment of inertia, was equal to mr squared. So we substitute. I1 becomes mr1 squared, and I2 becomes mr2 squared. In order to solve for omega 2, we cancel out m and then move r2 squared. Looking at the work right here, m was on both sides, so it cancels out. R2 squared was in the numerator on the right side, so we divide by it, so it cancels out, and we divide by it on the left side as well. This gives us that omega 2 is equal to r1 squared times omega 1 divided by r2 squared. We can now plug in our variables and solve. Omega 2 is equal to 0.25 meters squared times 5 divided by 0.2 squared. This comes out to 7.8125. Our original numbers all had two significant figures that we used, 0.25, 0.20, and 5.0, allowing us to round to 7.8. And since we're solving for angular velocity, it is measured in radians per second.